In this video, I'm going to go through the 2.1G lesson on word problems and application problems. Period 1 did not do problem number 2. Period 3 did do problem number 2. So if you've already seen problem number 2 and we went through that, you can go ahead and skip ahead in this video. Number 2 deals with an age problem, and it has two people, Talon and Peter. And as I write this word problem, I need to look at what's already set up in these expressions in the equation. So I notice that there is Talon's age will be t, and Peter's age will be t plus 3. So that would mean that, just as an example, if Talon was 5, that would mean that Peter is 8. Peter is 3 years older. So I need to incorporate that into my word problem. These are not the actual values of their ages, or I doubt they are. And the last thing I notice is in the equation, I'm adding the ages and I'm setting it equal to 39. And so that means that the combined years for Talon and Peter is 39. So let's write our word problem. The sum, because I'm adding these two ages, so I could just say that the added ages of Talon and Peter are 39, or I could use the vocab word sum. The sum of Peter and Talon's ages is 39. There's my first fact. So I've established what this equation tells me. The other thing I need to talk about is these two expressions. If Peter is 3 years older than Talon, comma, how old is each person? With a question mark at the end. I want to make sure I have a question about finding their ages to make sure that there's actually something for people to do as they read the word problem. Now I'm going to solve this equation, and in fact these parentheses don't mean anything because there's not a number in front that needs to be distributed. So I'm going to add up the t's, which gets me 2t plus 3 equals 39. Be careful that your t doesn't look like a plus sign. Then I'm going to do 0 pairs with the 3, meaning I'm going to subtract 3. That leaves me 2t equals 36, and I divide by 2 to get t equals 18. I go up to the top. I like to plug these in next to my expressions. And so this would be 18 plus 3, which is 21. So then I'll write my answer, which is therefore Talon is 18 years old and Peter is 21 years old. Number 3, we're going to look at a problem involving a rectangle. I'm going to sketch a picture just so I can think about this. A rectangle is a four-sided figure where opposite sides are equal in length. So the width is W, those are the smaller sides, and the length is the bigger side, which is W plus 5. So it's 5 centimeters or inches greater than the smaller side. The other thing I notice, and by the way, I don't know why these plus signs are so big, is that I'm going to add up all the sides and set it equal to 46. So this is the first side, the second side, the third side, and the fourth side. So they work their way around the rectangle, adding up all four sides. And they're setting it equal to 46. And that represents something we call the perimeter. You add up all the sides. So our word problem is going to involve the perimeter of a rectangle. So we'll start by saying the perimeter of a rectangle is 46, and we'll just choose a measurement, centimeters. The other thing I notice is there's a relationship between the width and the length. So let's say the width is 10, just as an example. That would mean that the length would be 10 plus 5, which is 15. So it's like the problem before with the ages, in that we're going to say if the length is 5 centimeters greater than the width, what are the dimensions? If the length is 5 greater than, because the length is going to be bigger, so add 5 onto the width, what are the dimensions? So let's erase this 15 and 10 because those were just hypothetical made-up values. And let's try to solve this. So I noticed these parentheses also are pointless because there's nothing to distribute. There's nothing in front of the parentheses. So I've got 1, 2, 3, 4 W's. 5 plus 5 is 10. I'll cancel out the 10 by subtracting 10 from both sides. 46 minus 10 is 36. 4W comes down. And I divide by 4 to get 9. So if the width is 9, then the length must be 9 plus 5, which is 14. So then my solution is, therefore, the width is 9 centimeters and the length is 14 centimeters. Whenever I do a rectangle problem, I find it very helpful to draw a picture just so I have a visual. Feel free to pause the video, but I'm going to go on to number 4. Number 4 is about making some lemonade. We have cups of water, which is 3x, and cups of sugar, which is x. So I need to talk about that. And my equation gives me another fact, which is I'm going to add these ingredients or combine them for a total of 12, and this deals with cups, so 12 cups. The relationship between 3x and x, let's say x were 2, then 3 times 2, this would be 6. So this is not addition where that was the case on the previous problem. This involves 3 times more water. So let's erase these values and write our word problem. So a batch of lemonade consists of 12 cups of sugar and water. If there is 3 times as much water as sugar, how many cups of each ingredient is needed? If there are 3 times as much water as sugar, meaning there's more water, how many cups of each ingredient is needed? So I'll just start by combining like terms. X plus 3x is 4x. Divide both sides by 4, and I get x equals 3. I go up, I like to plug it in my expression, so that would be 3 for the sugar, and 3 times what x was, which was 3, is 9 for the water. We'll write our sentence, so therefore, there would be 9 cups of water and 3 cups of sugar.